Okay, so the Qwen team has released Qwen 3. And like with many of their releases, this is not just one model, this is a family of models. And in this time, it's actually a huge family of models. If we come and look what they've already put up on Hugging Face, we can see the list of models goes on. Now, obviously, they've released some of the quantized weights, they've released base models, etc. But we can see we've got everything from a 0.6 billion right up to a mixture of experts, 235 billion parameters with 22 billion parameters active. And I think this is where it's actually really fascinating to look at what they've actually released. They've released two mixture of experts models, one being 235 billion with 22 billion active, and the other one being a 30 billion parameter with 3 billion active. And then on top of that, we've got 6 different dense models going everything from 0.6 billion right up to 32 billion in here. Now, you've got to admire just the sheer volume of models that they're putting out. Most companies would have done this as 2 or 3 different releases, had one release focusing on perhaps the mobile models or the small models, one focusing on the mixture of experts, one focusing on something in the middle kind of thing. The Qwen team has just put all of this out in one shot here. Now, there are some really interesting choices in what they actually have put out. And my guess is that we may even see some more releases, but in the form of much bigger models coming down the road. Now, there are a number of key things that are really interesting in these models that they've released. If we look at the biggest one that they've released here, they're basically saying that this is comparing to DeepSeek's R1, O3 Mini, even at times Gemini 2.5 Pro. While there are a couple of benchmarks that it's beating Gemini 2.5 Pro, it does seem to me that 2.5 Pro is probably a better model. That said, though, 2.5 Pro is not an open model that you can run on your own computer. And this is what this release is all about. These are all open weights models, meaning that you can use them as you want. They're all licensed with Apache 2.0. And for many of them, we've actually got the base models so that if you want to do your own fine tune for something specific, that is certainly something that you can do. Now, I will point out, as I've been going through this, is that it doesn't look like the base model for the biggest dense model and the biggest MOE are actually up, right? We've got the base models for the 30B with 3 billion active, and we've got the 14 billion model dense up there as base, but we're missing the 22 active MOE model and we're missing the 32B base model, which you got to think that both of those models are going to be models that people want to actually fine tune for their uses. I'm not sure if they're going to come out later or if that's a deliberate move on the Qwen team's part. Now, if we look at the key new features in here, we can see probably the biggest thing is them adding the ability for thinking modes or reasoning modes in here. So the idea here is that they want these models to be hybrid models. Now, we've seen this in the Gemini 2.5 Flash model, where you can sort of adjust the budget for the thinking. We've seen it in a couple of other models, but the idea here is that you can basically decide, okay, how much of a thinking budget or a reasoning budget do you want to give the model? Do you want it to go from having no thinking all the way up to really long extended chains of thought, etc. Now, they show some of the similar graphs that we've seen coming out of OpenAI and DeepSeek to show that the longer that you give this model to think, right, the more tokens that you budget for this thinking, the better the results that you're going to get out here. And with my limited playing with these so far, that does seem to be the case looking at these. And that's probably the biggest wow factor of these models. That said, though, some of the other features that these models are introducing are going to be really appreciated by a lot of communities that just didn't have models. So here I'm referring to the multilingual support, that they're supporting 119 languages and dialects out of the box. There's a whole list of them here. And we're not just talking about European languages in here. We've got a whole bunch of different languages, including Arabic. I know that's something people have commented on a lot in my videos, etc. We've also got a bunch of Asian languages in here, and not just always the sort of most popular or main language that's spoken in there. So for example, in Philippines, Tagalog is probably one of the main languages, yet they've got other dialects and stuff in there as well. So I've got to think that these models are going to be adopted by a lot of people who've just found that many of the models that people are making out there are not that useful to them because it cannot understand their own language or their own dialect. So the next key feature that they've added into the actual model is tool use, right? So they've improved the whole agentic capabilities of the model. And it seems to me that this basically means that they've trained these models to get better at being able to call tools. Now, up until recently, perhaps with the O3 and O4 mini models, one of the biggest challenges has been with reasoning models is that they just haven't been that good at calling tools. And in fact, as I'm recording this, just yesterday, I was at ICLR for the Deep Learning for Code workshop. And this is one of the common themes that came up in people's talk, was that one of the challenges that many of the academic researchers see for getting better coding models and coding agentic systems is getting these reasoning models to be much better at using tools, whether that's through sort of plain function calling, whether that's through Codact and other ways. It's going to be really interesting to see how that plays out. But it's great to see that the Qwen 3 model seems to have actually been trained for MCP and for some of these tasks as well. And as we can see here from this demo that they've actually got it to be able to use a variety of different tools that they can turn on and off, and then get it to use those tools to do plots, to do changes to files, etc., to do computer use, all these kind of things. Now, when we look at the details about training, probably the biggest thing that stands out here is to get these improvements, they've literally doubled the amount of training tokens for pre-training. So with the Qwen 2.5, they were up to 18 trillion tokens. With this, they're saying that there are approximately 36 trillion tokens used in the pre-training of the model. And that not only includes English and Chinese, but all the 119 languages. Now, it's interesting to see that they also mention in here this use of synthetic data for basically improving the math data and the code data that they actually used for this kind of thing. And this is definitely going down the path that the big frontier labs have been going down for a while, of supplementing sort of web data with synthetic data for very specific uses. Now, while we don't have a full academic paper yet, it is interesting to look at this blog post and see that they talk about doing just general sort of pre-training, I'm guessing with sort of web data, for 30 trillion tokens. And that was at a context length of 4K. And the goal there was to basically provide the model with basic language skills and general knowledge. Then they moved to stage 2, where they increase this proportion of knowledge-intensive data, such as STEM, coding, reasoning tasks. And you got to think that's where a lot of the synthetic data is being used. And then finally, once they've got that working at the 4K token context window, they then extend that out to 32K to basically make sure that the model can handle longer contexts before they do anything like rope or anything like that going forward. Now, their post-training process looks very interesting indeed. Here, it seems like they've got a number of different stages for doing this. And this is where they sort of split off the frontier models versus the sort of lightweight distilled models here. So they're starting off with long chain of thought and sort of cold start idea. Unfortunately, this is a bit vague, but I'm guessing that the sort of long chain of thought stuff means that they are actually bootstrapping it with that. But then they follow up with this RLVR, or reinforcement learning with verified rewards, in here. So that first stage is probably more traditionally like what we would think of as supervised fine-tuning. And they talk about this process is aimed to equip the model with fundamental reasoning abilities. How much of that is actually being bootstrapped from the pre-training seems a little bit vague in here. The second stage, though, seems to be a much more standard reinforcement learning from verifiable rewards in here, very similar to what DeepSeek R1 kind of did in there. The third stage, I think, in some ways is really interesting, of where they're sort of trying to basically incorporate more sort of standard supervised fine-tuning along with that long chain of thought data that perhaps has been bootstrapped from the enhanced thinking model of the second stage. And the fourth stage seems to be sort of a standard alignment or RL alignment, perhaps RL AIF, perhaps something along those lines, perhaps DPO, etc. The biggest challenge that we have with all of these things is that we don't know how many long chain of thought did they start off? How much of a cold start, inverted commas, did they actually use? Have they actually gone for more examples than I think DeepSeek went for a few 100,000 examples of this reasoning RL data? Have they gone for a lot more of that? And that's one of the things that they're seeing to be a big contributor here. And I hope that we will eventually get a paper that will allow us to see some of these numbers, although none of these labs want to seem to actually share the number of examples that they're using for different kinds of post-training, perhaps with the exception of DeepSeek, who actually did talk about it. Now, we can see that this process generates the two frontier models, the MOE models, and then the dense models are being distilled down after their base training with this form of distillation. Now, it's interesting that they don't tell us whether there's any alignment done at the end of these or not. I guess it's going to be worth sort of playing around with it and just seeing how well are these smaller models aligned compared to the bigger frontier versions. Okay, if you want to test the models out, you can actually come to chat.qwen.ai and you can actually try out the various, at least some of the big, more frontier models. You can see here that you can try out two MOEs and the largest Qwen 3 dense model in here. And just to show you that one of the things you can do is you can set, if you look down the bottom here, you can actually set the amount of tokens for thinking that you want to have or don't want to have in this case. Now, I've gone and generated a few different examples, all using the exact same prompt. And just to show you some things, okay, this is using the biggest model with no thinking on. So we tend to sort of jump into the answer. It doesn't have the sort of standard chain of thought that like a lot of the models last year would have of sort of building up to the answer. It just tends to jump straight into the answer. If we look at the exact same prompt, but with a thinking turned on, you can see now we get a lot of the sort of thinking steps going through this. Now, it's interesting that each of these is kind of like a mini little paragraph going through different sort of parts of the thinking before it actually then comes to its answer. Now, sometimes I've found the answers to be reasonably similar between the thinking and non-thinking version, and sometimes they're quite different. Really, you sort of need to experiment with that in here. And you can also see differences, although there's a lot of similarity between, say, the thinking version of the big MOE versus the big dense model, and even the thinking version of the smaller MOE. I'm definitely seeing some differences. I kind of feel it's too early for me to say that, okay, this one is way better and it's not worth using certain other ones. Playing around with the smaller models in code, it is interesting to see how some of these really small models are still generating out some nice thinking tokens as you go through it. One of the things that I do want to point out is that I do think how this model and how Google and OpenAI are training their thinking models is actually quite different. So if you take the same prompt that I put in here and you put it into something like Gemini 2.5 Pro, you will actually get much more of sort of the step-by-step thinking where each bit is numbered in here. And my guess is that the way they're doing the RL on these ones is much more like the paper, let's verify step by step, as opposed to just a verifiable reward, whether it got something right or wrong, and mixing the entire reasoning strategy, etc. in here. Now, personally, I feel that for certain types of queries, and especially around planning and stuff, seems to be much better on the Gemini models and the O3 model that have this much more step-by-step thinking as opposed to these. Now, that could be just that like we need to sort of prompt these a little bit different. It's still early days. And it's still really cool that they are actually able to do this with such small models. I think that is like a huge takeaway. Now, rather than me go through a bunch of tests of prompts in here, I suggest why don't you just come in and check it out at chat.qwen.ai yourself. Try it out for your favorite prompts, see what they can do. They do have search in here that you can turn on or off for different queries. And it looks like they're going to be adding a bunch of tools in here with this MCP element. Now, that's going to be really interesting to see if they do add a large variety of MCP tools in here, that actually could get a lot of people using this as opposed to the free ChatGPT or Gemini, where they've been pretty conservative in the tools that they've added into the online version and left it much more up to you to basically add your own tools in code, etc. So definitely worth checking this out. I will definitely be doing some more follow-up videos over the next few days or weeks of trying out some of the agentic abilities of this. I do see the fact that they've released the FP8 versions of these already is a good sign. Hopefully we'll get the base versions for the two biggest models, being the big mixture of experts and also the 32B version of this model. And you've got to wonder, is there a 70B version of this that's coming around the corner to be released soon, etc. Anyway, like I said, I will cover more of the agentic stuff in relation to this in another video. So look out for that later this week. Anyway, let me know in the comments what you think of the model if you've already tested them out. I'm definitely interested to see what people are finding as sort of the middle sizes. I've gone for just the 1.7 and the bigger models so far. So I still need to test out the 4B and 8B. It's going to be interesting to see how they stack up against some of the other models that have come out. But certainly we've got a lot of choices to choose in here. All right, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.